Hello everybody, and welcome back to another video. Now in this video, I have some sad news for you. If you are in high school physics, it is more than likely that your teacher has been lying to you about forces for this entire year, and they will continue to do so this year. Now, what do I mean by this? So the formula that F is equal to ma is not correct. Now, why is that? We will get to that later in the video. However, this is a gross simplification. Not really, it works for every application you need in your physics classes. However, it is a simplification. So let's first look at a problem where this does work. So let's say that we have an inclined plane of angle 30 degrees. So theta is equal to 30 degrees. And let's say that on this inclined plane, there is a mass 4 kilograms. So m is equal to 4 kilograms. Now let's say that for the sake of simplicity, g, our gravitational field strength, is equal to 10 meters per second squared. Now it is typically 9.8, that is the average on the Earth. However, this just makes the math a lot simpler. So let's find out what our acceleration of this block would be. So when we first look at this, we will notice that there is a force of gravity directly downwards, a normal force perpendicular, and that is the only forces because we are saying that there's no friction. Now this force of gravity has a component parallel to this board, to the plane, and a component perpendicular to the plane. So these angles, this angle right here, is supposed to be right. However, I messed up my drawing a little bit. Just imagine that this is a right angle. So what this does is by similar triangles, this actually places our angle right here. So this is our theta. So this, which we will call FG parallel, is equal to the force of gravity, which is the main one, times the sine of 30. Or in this case, this generalized case, it is just theta. So we can also get that FG perpendicular, this right here, is equal to FG cosine of 30. However, we do not need that for this problem. And these are, this is theta. I keep on saying 30. So what is FG? FG is equal to mg. So what that means is that FG parallel, which is in the direction of motion, so we will be using that for our MA calculation, is equal to our mass times the gravitational field strength times the sine of the angle of the board. So now, since we have FG parallel is equal to MA, and that this is mg sine theta is equal to MA, we can cancel out these m's by dividing both sides by m, and we get g times sine theta is equal to our acceleration. Now this is 10 meters per second squared times the sine of 30, which is 1/2, is equal to a. So we have that a is equal to 5 meters per second squared. So for this question, this actually does work. This is the correct answer, and you would get the same thing with the formula that I will show you right now. However, let's assume that there's a change in mass with respect to time. So essentially what we are saying is that the derivative of mass with respect to time is greater than, the magnitude of this actually is greater than 0. So it could be positive, it could be negative, but it is there and it isn't 0. So what our formula then becomes is what Newton actually wrote out. That force is equal to the time derivative of momentum, or the derivative of momentum with respect to time, where P is equal to mv, which is equal to the derivative of mv with respect to time, which through the product rule becomes dm over dt times v plus dv over dt times m. And if you notice, this is just a. So this becomes ma plus dm over dt times v, and that is equal to our force. So we have a new formula right here. You might notice that there's an ma here, so there is still this new term. So if there's a 0 change in mass, then this term just goes away and we are left with F is equal to ma. So your physics teacher has somewhat been lying to you a little bit. However, not too much. They just simplified this formula because they would not give you a question where there's a changing mass, unless if you are in AP Physics C. However, usually they will just give you an equation for the momentum and you will just take the derivative of that. You don't need to do any product rule, sadly. So I hope you all enjoyed this video and thank you for watching. Please like and subscribe.